it really is handy. This is something that you could use throughout your life. I'm pretty good about telling you when stuff is useful and not. This is one of the more useful things. So my objective for you is that you're able to identify and use similar right triangles and find geometric means. So geometric means are, like I said, super helpful. It's how they did it in the, the video that they did at the beginning, the Big Ideas video. It's how she figured out the height of the rock wall with just a piece of cardboard. So this is how it goes. It's when the altitude is drawn to the hypotenuse of a right triangle, the two smaller triangles are similar to the original triangle and to each other. So remember, similar means same angles, proportional sides. So this right here is what we're talking about. So you've got this big triangle, and you draw the altitude, which is from here down to the U, so that it's perpendicular. That's the altitude. And what it's saying is that it's creating two smaller ones. This one, which is a right angle, and maybe I'll do red. Sorry. And then this one here, which is also a right triangle. And those three are similar. So I redrew it over here. What we're going to do is we're going to identify the similar triangles in the diagram and write a similarity statement. Remember, all that means is we're going to say in order which ones are similar. So the best way to do this is just to redraw them. The problem being, here is RTS, and here is UST, and here is TUR. And if you don't want to keep switching your paper all around, just redraw them. Okay, so I've got my big triangle here with the right angle in this direction. Then I'm going to draw the bigger one here. Not quite as big though. And the T is going to be up here, the U is going to be down here, and the R is going to be over here. So that's the same direction. And then now my little one, I'm going to have to rotate it and flip it basically. Okay, so the U is down here, the S is here, and the T is here. Now, I'm just going to take a minute and color code. Because it's the first day I'm introducing this, okay? So here's my little green triangle. Here's the bigger red one. This is just sort of upside down. And then, of course, the big one is purple. So what you can write, here's the similarity statement. It's going to be RTS, or maybe I'll do RST. I'll start from here. RST is similar to, remember that's our similarity statement, RST is similar to RTU, it's got to go the same direction, which is similar to TSU. That's what it means to write a similarity statement. Okay. In this one, you're going to identify the similar triangles and write a similarity statement. So again, I've got this one here. This is a big one. And then I have two smaller ones. So I've got this one here. And I've got this one here. If you're one of those lucky people who can actually not color code and do this in your head, kudos to you. But otherwise, I would just redraw them out like this, and then I can write SQT is similar to RST, and that's similar to RQS. Now, for the sake of time, because these took a long time, they would take too long, redraw them here if you need to, but you'll see that that's, and again, those in those same directions. So, the way we're going to use this then is we're going to actually do problems with it. Okay, sorry, I'm adjusting my camera there. So if I have this one here, EFG, the big one, then I have two other smaller triangles that I can draw and solve that. So if I'm looking for X, I also have this one. You may also notice that this is a triple because it's a 3, 4, 5 triangle. And this one here is also a triple, a 5, 12, 13. We went over that in the previous section of notes in section 1. So because I cannot do things upside down and I can't move I'm not going to move my paper around, what I'm going to do is just draw these other two triangles so they're in the same direction, okay, so that I can see which one it is I'm going to use. So this one is EHG. That's going to be this one over on the side. And this one here is GHF. And I'm going to label it. So this is X, and this is 3. EG is 3. And then here, GF is 4, and GH is X. So the thing about similarity is I can use either one of these and write a similarity proportion with this and then solve for X. It doesn't matter which one you pick. It really does not. Just pick whichever one, well, in this case, just pick whichever one looks easier to you. I am just going to do this color code because, you know, I want to make sure that I'm making sure the right thing. So I think what I'll do is I'll choose this one on the bottom here, and I'm going to write this proportion. So that means that in this big one and this one, I'm going to write this hypotenuse over this hypotenuse. So 4 over 5, I'm going to let that equal X over 3. You could have also written 3 over X equals 5 over 4. You know, none of that matters. You could have done it with this one. Well, it's just the whole point is that whatever you keep that similarity statement, you do it. And then you do cross products. So you get 12 equals 5x. It says round to the nearest hundredth. So they're saying it's okay to use a calculator here. Just grab your calculator and do 12 divided by 5. And I get 2.4. So x equals 2.4. So any questions right now on that? All right. Same thing here for the sake of time. I'm not going to actually do this problem right now because I would prefer to use it more in geometric means, but I am going to write the answer here. If you do this on your own, you should get 4.62. Same exact problem, just different numbers. So unless you have a question, raise your hand now. I'm not seeing any other hands raised, so I'm going to go on. All right. Now this is an example where you would use it in real life. Yay, real life problem, woohoo! That's really what we want to do, right? We want to actually use some of our math in real life problems. So here's our first one. We've got a roof has a cross section that is a right triangle. So here's my right angle. The diagram shows the approximate dimensions. Find the height of the roof. This is what I'm looking for right here. Round to the nearest hundredth if necessary. So again, For my sanity, I'm going to color code. I'm going to make that green. I'm going to make this red because that's how I roll. All right, so I've got the big one. And then this one, you know what I'm going to do to make it even easier for myself? I think I will redraw this upside down so that my square root down here is over here because I have a better time looking at it this way. So then my short side will be 3.1. My hypotenuse will be 6.3. And this is 5.5. So let me go ahead and label this. This is Z, this is Y, this is X. Then I can redraw my other two small ones over here. It's not so traumatic on me. Okay, so my small one here, I'll go like this because I know that my hypotenuse is 3.1. The bottom of it is H, and this is Y, W, and X, and I don't know what that side is. Right, I don't know what WX is. Then the medium size one, again, I'm going to draw it in the same direction, so it's corresponding. Let me just make sure I label that. This is the green one. And then this one is going to be Z, W, Y. This leg is H. This hypotenuse is 5.5. I don't know ZW. That's on the bottom there. That's okay. But here's my red one. So now that I have everything drawn, this is, the actual numbers aren't that hard. What's hard is making sure you get them all in corresponding areas. Okay, so let's look. I think I could use this and this, or I could use this and this, and it doesn't look any easier to do the one way over the other, so I guess I'll just do these two. Okay. So that means I'm going to write 3.1 over 6.3. So hypotenuse over hypotenuse equals, and I want H, I started with 3.1, so H over 5.5. That's the amount of the work that goes. This is the part where you have to come up with this equation. And then you can do your cross products. So your cross products from here, I'm going to have to round it to the nearest hundredth. Remember, it's going to be 3.1 times 5.5. That's going to give you those two, and you're going to divide by 6.3. So divided by 6.3. Of course, I would prefer you write it down on your paper. Look at me, not setting a great example. And that is closer to 7.1 than it is to 7.2. So I'm going to round it to 0.71 because it said 100th. Okay, so any questions so far? Now would be the time to ask. These should look a little bit familiar simply because we've already been doing similar triangles. So the new part is this altitude thing and getting 3 of them. Now, I actually have some theorems that will help you out, that will help you figure out which is which. And it may be to your benefit. So there's something called the geometric mean. The geometric mean is 2 integers, A and B, is the positive number that satisfies this equation. It's a very simple equation. These are just numbers, okay? But X is so that if you do cross products like this, you get A times B equals X squared. And of course, we don't want X squared, we want just X. So you would square root both sides, and you'd get X equals the square root of AB. Now, technically, that's a positive or a negative, because if you do negatives, they'll cancel. But that's why we say that these are 2 positive integers. So X is equal to the square root of AB. We're even going to put a little pretty around it. Ta-da! X is equal to the square root of 80. Okay, so this is how that works. Find the geometric mean in 24 and 48. This is a classic problem on standardized tests like SAT or ACT or even the CASP. So, and that's all it is. It's just find the mean of 24 and 48. This is how it works. X equals the square root of 24 times 48. That's it. So let's figure out what that is. It also tells us to find the exact value, so that has to do with the square roots, and the nearest hundredth, so that's decimal. So you'll have to do both ways. So 24 times 48 is, holy cow, 1152. I don't know what square roots of 1152 are. I'll bet you don't either. So, I have a better strategy for you. If I'm going to have to break this down to square roots, why don't I just break down 24 and 48? I know how to do that, right? So, in fact, let me just go over here because I think I'll need a little more space here. So what I'll do is I'll break down 24. It doesn't matter if you do 2 times 12, 3 times 8, or 4 times 6. But I'll do 4 times 6. And then 48, same thing. You've got 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So you can use any of those. They'll all work. Let's just say I do, let's say I do 6 times 8. I'll do 6 times 8. 6 times 8. Okay, the trick is here, you just have to keep going until you get them all into those prime numbers that are not square numbers. So this is root 2 times root 2 is 4. This is root 2 times root 3 is 6. This is root 2 times root 3 is 6. And this 8 is actually 2, 2, and 2. Whew. Look at that. Holy cow, I got a bunch. But that's okay. Just remember that anytime you have 2 of them, you can take them out. Because, like for instance, this is 2. It's the square root of 4, which is 2. So that can come out as a 2. These can come out as a 2. These can come out as a 3. And these can come out as a 2. So X is going to be, this one will give me a 2. That one will give me a 2. That one will give me a 3. That one will give me another 2. And this lone root 2 over here is still hanging out. So all I have to do is multiply. 2 times 2 times 2 is 8. Times 3 is 24 times the root of 2. So that is exactly what the geometric mean is. And then remember, if it says round, then that's when all you have to do is you go 24 times 48. You get that 1152, and you press your square root button, and you get approximately 33.94, because that's closer to 94 than 90. So 33.94. So if it exact value and round. So this is your approximation. I'm going to box it up so I know that that is my answer. Any questions right now? Okay. I know it's a lot of notes. I'm going to keep going, but now that you see exactly how a geometric means with just numbers, now let me show you how it's going to help you out with similar triangles. So, think back to geometric mean. In right triangle ABC, altitude CD is drawn to the hypotenuse, forming 2 smaller right triangles that are similar to ABC. From the right triangle similarity theorem, you know that CBD is similar to ACD, which is similar to ABC. Because the triangles are similar, you can write and simplify the following proportions involving geometric means. So this is the beautiful part. We can write AD over CD is equal to CD over BD. We can also write, nope, I wrote the wrong one. Sorry. For this one, AD is equal to AC which equals AC over AB. For this one here, AD over CD. So AD over CD is equal to CD over BD. AD over CD, CD over BD. And we can also write BD over BC, BD over BC is equal to BC over AB. I know this looks kind of funny, and they're not exactly matching, but the point is, for each one of these parts, you can write these proportions. So for this one, if I do the cross products, right, I get AC squared is equal to AD times AB. For this one, I get CD squared equals AD times BD. And for this one, I get BC squared equals BD times AB. Which hopefully you can recognize as the geometric mean. Okay? So for each one of these, again, AD is like a bottom over the hypotenuse equals AC, which is the bottom, over the hypotenuse, AB. Here, AD over CD is the bottom over the long leg over the short leg, equals long leg over the short leg. And you can write short leg over hypotenuse, BD over BC, equals BC short leg over hypotenuse AB. So they're all sort of interchangeable. Hopefully this you see as the geometric mean. So questions so far? Really, it's not going to make a ton of sense until you practice with it, which is what we're going to do now. So I'm turning the page, and I'm giving you two really great theorems. Okay? So you can read them. Turn off that stupid beep. The geometric mean, or the altitude theorem. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So again, we're talking about CD. That's your altitude. But this is talking about two segments of the hypotenuse. So AD and DB. The length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. So that means CD is the mean, like that, between AD and BD. Or if you want to think of it as that altitude squared equals those two lengths times each other, AD times BD. Isn't that kind of cool? So there's your AD, there's your BD. In fact, since I'm at it, let me add a little bit of color coding here. Okay? All you have to do is multiply them, and that's your square. Now we have another theorem. It's very similar. This one has to do with your legs, and it can be either leg. So I hope that this doesn't, hope it doesn't confuse anybody. But, so we have altitude and we have leg. Now, same picture. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So again, we're talking about these two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that's adjacent. So let me just go ahead and clarify that for you. It's talking about this leg, AC. That's the leg of the big triangle. That is the geometric mean of AD times AB. Okay, so from here to here, that's your small leg on ABC, but then AB is your hypotenuse. So hypotenuse squared is equal to that leg and this. Also, the other leg, which is going to be BC, right? So BC is equal, squared, is equal to this small side, BD, and AB, which is the whole hypotenuse. So that's what it's saying, is it is the geometric mean of the lengths of the hypotenuse. So AB is in both of them, that's the hypotenuse, right? And the other leg. But I can't draw them both that way without taking a different color. So, believe it or not, these theorems are super helpful because you don't have to redraw them all the time. That redrawing, that takes a long time. So what we're going to do here is we're going to treat this like the big ABC, and we're going to try to figure out if we can find those sides. Okay? Find these sides, X, Y, and Z. First theorem we're going to use is, what's that first one called? Not the right similarity triangle theorem. It's this one here, the altitude theorem. Okay, so we're going to solve for x using the altitude theorem. What that means is x squared equals these two sides, 6 times 3. That's how you use that theorem. C squared is equal to A times B. C squared is equal to A times B. So then you just do the square root of 18, which is 9 times 2. And so that's 3 root 2. Bam. That's how you use it. Isn't that so much easier? I just think it's amazing. Amazingly easier. Okay, we're going to continue because there's a little bit more. Now, if I want to, I'm going to use this theorem for all of them. Okay, so say I also want to find y and z. Then I'm going to use this theorem. So y squared equals 9 times 6. So here's y, that's a leg. 9 is the hypotenuse, and 6 is the other longer leg. So y is equal to the square root of 54, which is 9 times 6. I probably could have gone straight there. And that is 3 root 6. And then now that we have y, last one is z. And again, we're going to use this theorem here. Z squared is going to equal the hypotenuse times the shorter leg, which is adjacent to that. And so z is equal to square root of 9 times square root of 3. So z equals 3 times the root of 3. That's how you use those theorems. Again, there's a little bit more examples here. So what I'd really like to do is flip this over. because I want to make sure that we get to this part. And, you know, we only have 10 more minutes. So this is the rock wall problem. This is the one that we started class with, okay? To find the cost of installing a rock wall in your school gymnasium, you need to find the height of the gym wall. You use a cardboard square to line up the top and bottom of the gym wall. Your friend measures the vertical distance from the ground to your eye, which is 5 feet. And the horizontal distance from you to the gym wall, which is 8.5. Approximate the height of the gym wall, round to the nearest hundredth. So, we're going to use this theorem. This is the height. This is my big right triangle. So that's my altitude. Okay, so it's going to be 8.5 squared equals, like I said, this gets cut up into two parts, right? 5 times W. That is literally all you're going to do for this gym wall that is part. So 8.5 times 8.5, couldn't tell you. It's 72.25. It's equal to 5W. So W I'm going to have to divide by 5 on both sides, which is 14.45. Said hundredths, so we're good, and those are feet. Oh wait, now it says we have to add this too, right? Because we want the height of the wall. What we just found was W, so we have to add 5. And that means gym wall is 19.45 feet high. Okay. Any questions right now? All right, I know I've taken up most of your day. We're just going to do a little bit more since you can't get started now. But let's see how this one works out. I actually didn't work this one out, so let's see. One of the things we can do here, we've got the same situation, is we can say 12 squared equals x times 16. 12 squared equals x times 16. So that's 144 equals x divided both sides. That's not too tough. 144 divided by 16. Look, it goes in equally, so x is 9. Okay, so that's a quick way to do it. And then this one, remember, if you're going to solve for stuff, you can say that x is equal to 15 minus y, or you could say that y equals 15 minus x. And these examples are actually in the other video that I made. But right now, I think I've taken up all of your time. I think you're all glazed over. Nobody has, sorry, I don't mean to take so long. I'm going to stop here, and hopefully that's enough to get you going.